Welcome. When solving quadratic equations, ax squared plus bx plus c equal to 0, we have often had integer coefficients, which is really nice. Sometimes we'll have coefficients that are not integer values. Decimals in particular can be a little bit tedious and annoying to work with, especially when it comes to completing the square. So we say, yes, at times it's convenient for us to come up with a formula, which is awesome. We can do that. We can apply the method of completing the square to the general quadratic equation as written here. And by doing so, we end up with a result in terms of the coefficients a, b, and c, solutions for the quadratic equation. This thing here is called the quadratic formula. This does provide the two solutions. In this formula that we have here, we have this thing, which looks kind of weird, but it's a plus sign over a minus sign. So we have negative v plus that, or negative v minus that, all over 2 times a. All right, what I'd like to do is I would like to share with you how we get this, right? I've already said we find it by completing the square, so let's go ahead and do that. So I start off with ax squared plus bx plus c is equal to 0. What I'm going to do is I'm going to subtract c from both sides to get ax squared plus bx is equal to negative c. And then I can divide both sides of the equation by a, because I want to remove that coefficient of a. And actually, maybe what I should do first is just pull it off of both terms. So let's write it as a times x squared plus b over a times x is equal to negative c. Now I can more clearly divide both sides by a to obtain x squared plus b over a times x is equal to negative c over a. This doesn't look particularly convenient. That's okay. We can still use the method of completing the square, even though it looks messy. I'm going to recognize that I want x squared plus 2 times something. So I need that b over 2a times x. I want to add something to complete the square. This is equal to negative c over a. And whatever I added to complete the square, I have to add to both sides. Now, this is precisely the thing that I need to add, right? This thing squared. So I have b over 2a squared that I'm adding to both sides. That looks pretty good. The left-hand side I can now recognize as x plus b over 2a being squared. And the right-hand side, it'd be nice to write this as a single fraction since I'm going to take the square root of both sides. B over 2a being squared is going to give us b squared over 4a squared. I would like to add the two fractions, so I need to introduce a factor of 4, and I need to introduce an additional factor of a. So this is going to be, let's see, again, introduce an additional factor of a. So I have a negative ac times 4. And that gives me the desired denominator of 4a squared. And I am adding b squared and 4a squared. That looks pretty good. This should look somewhat familiar at this point. I'm going to end up with x plus b over 2a squared is equal to, I can add my numerators here, I combine under addition. So b squared minus 4ac. And this is over 4a squared. Now I'm going to square root both sides. So doing so, I have the absolute value of x plus b over 2a, absolute value here. Again, this is a quantity being squared. When I square root it, I get the absolute value of that quantity. When I square root the right-hand side, the numerator is simply b squared minus 4ac, and that denominator I can take the square root of. Square root of 4 is 2, and the square root of a squared is technically the absolute value of a, but I'm going to just write it as a. Mostly because I already have absolute value on this side of the equation. So I'm going to end up with a plus or minus over here anyway. So it doesn't matter whether this numerator is positive. This a value itself could be positive or negative, but it's just going to switch it back and forth when it gets switched back and forth. So we could distribute this out a little bit more. It's true, but I'm just telling you for now, it does work out that we can simply write this as a, and the correct solutions will still follow. So I get x plus b over 2a is equal to, let's see here, I can take the positive version or the negative version, and to simplify that, I just write it as plus or minus square root b squared minus 4ac all over 2 times a. I can subtract this from both sides to get x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac all over 2 times a. But of course, we have a common denominator here, so we can write it as a single fraction. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So we just use the method of completing the square on the general quadratic equation, and the solutions that we find are what we call the quadratic formula. Again, that's written here. Thank you for your time.